So for those who have not been there on the hands-on session yesterday, there is some materials here on the USB sticks. So if you have already followed my hands-on session yesterday, you have already everything you need. But for those who were in the parallel session, there is some material here copied. So there are two folders. One is called with Docker and one is called without Docker. And so you just need one of them. If you're using Docker, you can copy the one with Docker. If you're not using Docker, you could just copy that.
Okay, so welcome to the hands-on session 1.2, retrieving satellite and reanalysis data from Earth observation servers with Nathaniel Wong and Alexander Bartz. I already presented Alexander yesterday, but I didn't present Nathaniel. So, Nathaniel is a fourth-year PhD candidate at Harvard University studying tropical climate dynamics using a range of tools from satellite observations and reanalysis datasets to climate models that range from idealized small domains to global models. For the past 3 years, he has used Julia to aid in the retrieval and analysis of various climate observational datasets, and in the future aims to use Julia to help speed up the analysis of climate model output. Currently, he works under Professor Kwang in precipitation and moisture dynamics over tropical islands, and continental regions. Thank you.
Okay, so Alexander will be handling the first half an hour to an hour, and I will be taking the data session because my session will be on his.
Can you switch on your project? Easy enough.
These damn technologies.
I don't want to mess with it. It looks so realistic.
Is there a new audio file? Yeah. Okay. Same.
So if you could pass the pen drive all the way. Thank you.
Is there only one or?
There are two.
Okay, so everything you need to know about how to get started is on this web page. So for the first part of the lecture, so so please go to this address https://tinyurl.com/JuliaEO21. That's the same also for the lecture before. So that there you have the instruction how to.
Again, we need you to get in Zoom. Share screen.
Okay. Let's set up Zoom. Where again do I find the Zoom?
You didn't receive an email as a panelist? If not...
It is also on the web page?
No,
No,
on
she
your
sent an
email.
email.
Pen drive you passed yesterday is not the one that you passed in the beginning of the day. With the Docker and without the Docker is the same that you're referring to? Ah, okay.
If you have it already
Okay.
copied, then it's already fast.
Yeah. So to send you again? You have Katarina Paz Duarte.
The one at 11 o'clock, 11:02.
This one here.
This one is
okay. Thank you. Do I join with video or without video? Or
Without video, without sound.
Without video, without sound. So, continue without sound, continue.
Again, straight screen.
I'm muted by default right now. Then share the screen.
I think first open the session on the second window behind.
Share screen. Okay. Doesn't work.
Yeah, I managed to fix this. I'm not sure. I think you're not logged in yet, are you? There's a window behind, that's in the second window.
So here.
No, behind this one, the window. Yes, open Zoom, right?
Oh, I already opened it. Maybe I'm not allowed to share my screen?
You should.
I can share my screen.
Maybe it's because he started without video.
Olha, é isso. Share. Tá certo?
Just,
Tá.
or maybe I'm just trying to start my video. Maybe I can-
Ah, yes.
No.
I'm trying.
Join with video.
Yeah.
Tentei imaginar. Claro,
Yeah,
claro.
It's okay, it's
Claro,
okay.
claro. Duh.
Dani mi
Join with computer audio, join with computer audio.
Recording in progress.
And now start sharing.
Maybe this is sufficient for participants. I don't know.
No, I logged in using the same one and I got the video.
There are different. Also from the 11 o'clock?
Yeah.
Olha, põe tu.
Catarina tem que ligar.
Não, mas ele certo. Deixa eu ver. Não, não é preciso. Espera aí, espera aí.
Join video?
It was not supposed, it's not
Tá
supposed to.
bem. Mari.
I can just, I think we can try it. Just try to share my screen.
Okay, yeah.
Yeah.
Recording in progress.
That's the browser window. Everything is in the browser. The Chrome is in
So this one, right? This one, right? This one.
Sorry about that.
Yeah. But thank you so much for waiting. Sorry for this problem. So it's the very first part of the hands-on session. I will speak a bit about NC datasets, which is a tool that should manipulate NCDF files. And the second part, Nat will is his other packages, which are some of them which are built on NC datasets. So that's the reason why we start. So here on the NC datasets package, there are some tutorials, but maybe just to be sure that I have everybody here on the same page, I want you to follow here's instruction on this web page. Okay. So obviously you don't see it here. So follow instructions. So these are the instructions in order to get started. Yeah. So this on this web page you will see what you need to do to get Docker started. But I already used Docker sometimes during this week. Maybe this works as well. But you can also use the native Get package. Okay. So so if you are here, the idea is that unless you already participated in the hands-on session yesterday, you have already the Docker image loaded. But if not, that's the command that you need to use in order to load the image. Okay. And then as before, you go to the directory containing the notebooks and the image, and then run start with Docker by copy pasting this command. Okay. And then you paste this web address, the one starting with HTTP 127 and so on. So the full address you need to paste it in the web browser. It's not automatically, you need to paste it manually. Okay. But if you want to use directly Julia's package manager, you can do also as well. And here are the instructions that you hear. A very important thing and not to forget is that you change the directory, you need to activate the environment and then instantiate all the packages. That's very important. Okay. So, and if all this works, you should have a page like this. You should have a notebook, the notebook page. So maybe just raise hand if you have. So, is it clear for you what to do? Okay, but I guess you're not there yet, right? So you are still loading the image, maybe, or still open it up. So if you have any error message, please raise your hand, and then I can have a look what might be happening. So here, this one. Yeah, go this one. No, this. Is this the file on the drive? Okay. Yeah. Can you scroll down to see? Yeah. So you should have a file which is called SST-mets.
SST Max.
Do you have it?
Just have
Who has the pen drive?
Here. Yeah, for some reason, it's on the pen drive, but for some reason, oh, I didn't have it. This one SST. That's
the not Max, okay.
Can you expand to find it? To just
Yes,
show it's ended with slice one. But yeah, it must be this one.
Yeah, okay. But it's image director.
Somebody needs the pen drive? So who already got to this page? Okay, very good. And who has some issues or error message?
Before
Just downloading packages. Have to install the first few packages, that's all.
Okay, but you don't use the Docker image?
No.
Okay, then yeah, then you have to install
install
it.
it.
I just have an error before that line.
Okay.
Experimental variable that's used for username and password. Obviously, I can get.
Oh yeah, that's something we need to change.
This file here is SST Med. In my case, this file is missing SST Med, and it is in the wrong for reason.
Não é esse, tens que pôr o teu. Se tiveres, tens que registrar.
Okay.
Onde é que eu vou
So
buscar
the idea was
This is
that
still
you...
underlined by
Sim.
shipping to
So you did not do the
Tem que
installation.
instalar?
Não, basta o diretor.
Yeah.
Ah, tá.
So it's no
Mas
needs
tem que instalar.
It's
Vai faltar no meu diretor.
Será que vai buscar o teu?
Okay, yeah. Downloading stuff unfortunately takes some time, especially if the Wi-Fi is not that fast. That was actually the basic idea of the Docker image, that you have everything already in the Docker image. But okay. So in the example here, I showed you a bit how to access data from CMEMS and from NASA. And unfortunately, they require more and more authentication, so they require you to register to access the data. They are still free, but it's a bit more complicated for to access the data. And so the idea is that so I don't know if you received the message, but I asked that you register for CMEMS and NASA Earth data. I don't know if the message has passed around. Okay, so so if you have a CMEMS username and password, the idea is that you can put it here. Yeah? But I already anticipated that maybe some of you not have CMEMS credentials. So you can just skip these steps. Yeah? And I already prepared you a slice of the CMEMS data on the USB drive. Okay, so this saves us also to do some downloads. So but just to let you know what is the essential step you need to do. When you have a URL, actually to a data set from CMEMS over distribution over OpenDAP, you have to put here in front your username, colon, password, and then the address. So that's relatively straightforward. That's the usual HTTP basic authentication method that works for CMEMS. And this this command actually does it automatically. So if you have username and password, it's like this. So here, at this place, you would typically remove this and put your username and password there. It doesn't work for you. This is just for me. I don't want to expose my username and password here. And therefore I use some environment variables to get these credentials. But don't worry about this. We have the netcdf file already on the already there. Okay, so it's a quite big data set, and I just downloaded, just extracted for you the very first slide. Okay. So obviously you cannot close the netcdf file if you didn't open it. But so if you uncomment this line, you should be able to execute this one. Okay. So at first we load the packages. So this is very important. We always need to load the modules, NC datasets, PyPy statistics, and theories. And if this is done, let's jump directly here. Okay. This one, let's put a hashtag in front of it, and we are opening the next one. Okay. So just to know, did it work for you? So just let me know if you have some issues.
I have a problem with Firefox. Always having this problem. I don't know why.
But you didn't use the Docker image, right?
I'm using this.
Oh, you did.
Actually, the same folder as the file. Yeah.
Oh, this is something that if you don't use
Yes, but I will.
Question, is this an M1 Mac?
I think so.
Because if it's an M1 Mac, there's usually a problem with, there's always a problem with Conda and Python. If you're not installing the correct version of Julia and the correct version of Conda. You need both to be either Intel or both to be M1.
Okay, what I can do there. Yeah. Don't worry.
Can I just?
Yes.
Oh, I mean, where are your brackets? You're closing them?
Para manter o plano aberto, assim, quando ele está a apontar para o quadro, para quem tem a adição da gravação ficar aberto, ou seja, esquece.
Mais um bocadinho.
É, exatamente, fechar um bocadinho até aqui. Senão depois na gravação não fica, ele está a apontar para cá.
It's done. Let's go with squared brackets.
That was. same
No, your home
environment
directory,
also
your
has
user
directory.
directory.
And there are things which are currently not working on anymore, but the ones they use today should work, or are not.
Okay, good.
So now it's
Okay,
still
proceed.
so that it's working.
Thank you.
You comment on this one. You need to comment on this one because this is the original URL, and then you try to load it, but you're skipping the steps, so you don't use this.
Thank you.
No, it's going because of the.
Because that's not
Because of the. It's from my C driver, right? Because sometimes
yes,
I put
yeah.
out of that and it gives me.
It's just the relative path of where it is in the notebook.
Okay.
Relative path.
Eu consigo fazer uma arquitetura não.
Another important thing on Windows, when you use a backslash, you have to put raw in front of the string, or use double backslash.
Okay.
Because the backslash is also a special character for strings. Like backslash n is a new line.
Okay.
So Julia needs to know is backslash n literal backslash n or is it a new? So typically use either two backslashes or raw A R W before the string.
Everything working?
Yeah.
Yes.
Working, but
Still
it's
installing
crazy.
a lot of stuff. Right?
Yeah, you need to install everything.
You don't want to be able.
Thank you. Yeah, it's doing it
And it's really weird because I'm pretty sure you already have Python installed.
Yes,
I'm
yes.
installing just a different
I
version.
do. Thank you.
I think like eventually like the best is usually is when you're doing installation, you do installation inside the terminal. You don't do installation inside a Jupyter notebook. Jupyter notebooks tend to make everything
Yeah, a bit messy. Yeah, the output is a bit
not messy, but it's also slow. I feel.
Okay,
Yeah.
thank you for the
Like if
suggestion.
you all these right, you just go into
The terminal.
you go into the I'll show you
You're going to?
I will somewhat go through using the terminal later.
Okay, okay.
Yeah.
Good.
Yeah.
Okay, so I propose that I continue.
If you're using
So you're still installing some things, or do anybody, if you have some error
I
message
am
or some
struggling,
words,
but now I don't know why. Yeah.
or do you see something like I do here? So if not, please raise your hand and I can have a look. But if not, I will continue. So the netcdf file is structured that you have different variables and attributes and dimensions.
I can help you with that. Okay, I can read.
And when you open a netcdf file like this, yeah, you will essentially get a dataset object which represents your netcdf file. This can be a file path, but it can also be a URL on the open up. So, okay. And so per default, the output when you just open a netcdf file without so if you put a semicolon here, it would be quiet. But if you omit the semicolon, it will output all information, essential metadata about the netcdf file. It will not output the data itself, that would be too much. But it will tell you the dimensions that are defined and the variables. A bit special about netcdf data format is that coordinates are not special per se. They are just other variables. Yeah? And let's choose the names that you know, okay, the underlined SST has dimension which are called longitude, latitude, and time. Yeah? And then we have also other variables which are called longitude, which has also the same dimension and longitude, and these are then the coordinates of every grid cell. Okay, and the OpenUp server from Siemens is a Mediterranean surface temperature for several years, but just to make it small, I just downloaded the first time. So therefore we see just time here, time And you see very, very basic things like like the units which are defined here. So sometimes as an oceanographer we like to work in degrees Celsius, but other people like work more in Kelvin, and so here that's this temperature is also in Kelvin. And when you want to just want to know, so DS actually behaves like a dictionary. Yeah? And a dictionary is a type which associates some string, for example, with a value. Okay? And if you want to know all the values, all the keys in the dictionary, you can use the key function, and it gives you all the variables. Okay? And then later on, you can then access a variable using DS data, and then the key. Okay? So if you execute this line, your NC var would still be an NCDF variable on disk. It will not yet load the data, and you will still have all the attributes. Yeah? So if you want to access one attribute, one particular attribute, let's say units, yeah, you would use it with NC var attribute units. And so in a well-behaved netcdf file, you have units defined and all the attributes like standard names and long name. But sometimes you need to query, okay, is long name defined or not? And that's, for instance, the function hasKey. hasKey. So here, do you have the attribute? Oh, do you have the attribute true? And it says false, but it has the attribute units. Okay, so and then any questions so far? What is your so who just as an idea, who of you already also use netcdf files? Okay, that's what kind of operations you typically do when you use netcdf files, like I don't know, subsetting, aggregating, or computing averages, or you're using them to force a model or something?
I just use it for subsetting.
Subsetting,
and,
okay.
Ocean color.
Ah, yeah, okay. And so actually netcdf is really well optimized for this use case of subsetting. Okay, so in the if you have a really large array on disk, yeah, you can easily subset it without loading all the data in memory. So that was one of the primary use cases where it was optimized for. And if you let's check the size of NC var, yeah, and let's see if you want to load a subset. Just for instance, just the 10 by 10 elements, you can do this like this. Okay. But another use case, so this is subsetting with indices. Another thing that I recently implemented it in NC datasets, that you can also subset by longitude and latitude values. So that's something that's so if you want to have all the data, let's check the bounding box, let's say from -10, 20, and okay. So if you can also subset by longitude, latitude. So typically you're saying here, I want all longitude data between -10 and 10 degrees, so everything which satisfies this first condition and satisfies this condition. And you can also do some basic operation on this, like Like if you have time, for instance, you say, okay, I want to have every data set, for instance, just leave it here. Just make another example. So time is also defined in the netcdef file, and you want to extract a given month, for instance. Yeah, you can just say dates, months, time equal to 1. This will get all the data.
I have a question for this one. Does this work for OpenDAP as well?
Yes.
So basically, if if I wanted to retrieve data from OpenDAP and I did this selection, I wouldn't need to it would just select on the server itself the netcdf of this particular range, and then I can just download it.
Yeah, exactly.
Very nice.
Yeah, and it also works on the whole netcdf file. So, for instance, you can also let me check. It also works. Sorry for scrolling. It also works on the whole data set. And then you would have, it will subsample all the variables. And if you want to just then save it to disk, you can just write then it will save all the data to this. So typically, if you have an opened up server with a large data set, so this is a convenient way to get just a subset. So, any questions so far, or maybe I was a bit fast. Do you want me to? I will just suppress the output here, so that you see all the lines simultaneously. It's maybe easier if you need to copy things. So here we're subsetting via indices. This is great if you want to really be precise on the grid cells that you want to keep or not. You can also select based on coordinates, longitude, latitude. That's typically the most of the time you are interested more in this. You can also apply some Julia functions to the coordinates. So, for instance, if you want to apply the date months function to the time coordinate, you can do it.
Excuse me.
Yeah.
I'm getting an error on the right function.
So do I.
It says it's not supported on non-is-bits array.
Let me check on which function.
This one.
And so, can you scroll up so the DS stuff work well?
Yes.
Let's go above.
Mm.
Okay, that is defined. Right?
Yes.
Yes. Okay. You run this one, then I need.
It has to do
Yes.
with the system itself, operating system, or the processor, something like that. So we have an ARM processor.
Yeah. So, yeah, that can be. It can be. I don't.
Sorry, I hate Windows.
So it is only tested on the Intel
Okay, maybe that's
CPU.
it.
I'm really surprised. Did you also have an error on this?
I'm going to do this now.
Okay.
Yeah, I had the same thing last time.
It is also an ARM processor?
Yeah.
Okay. So we found out. ARM is like this work.
It's
Looking at different.
Falta-te dar uma variável do subset.
Mas isto ainda é na source search do data from now.
Qualquer coisa igual.
Yeah, I'm sorry about that. Okay. Yeah.
But this is before this part, right?
Do I have to put brackets
Yeah,
because
yeah, yeah.
one, it's like the first index, right? The date's not one, is it? Does it mean like this?
And just so the errors at the right.
Alex,
Yeah, the same problem.
there's another one. The multiple coordinates in expression.
Deu erro.
I haven't seen this one.
Mas nesta parte.
No, on the right.
Ah, no right.
Oh, sorry. I think we have a collaboration. Okay, which doesn't have to time.
There's just one, what is it? This is the only one.
So. Can
He didn't.
It didn't work, right?
For me it worked.
For you it worked?
Yeah, I have a
Maybe not.
It's good.
So this is my
A dele está verde.
Okay. Do you have?
Yeah,
sorry.
Do you have terminal?
Normally SST in an example has
Times one, yes,
times one.
yeah,
That's the
sure,
difference.
yes.
So that, therefore
Yes.
this example doesn't work. But
Anyway, doesn't change it. Okay.
okay.
Copy this. Take this.
Yeah, that's for Thursdays. I will do it. I don't think we have a. Essentially, what you need to do,
Trying to get the backslash.
you need to create these files with your username and password.
Okay.
But only if you have Earth data.
I should have one.
Yeah.
You don't
So
restart
what
because
happens
it's
is
only when you restart.
NC datasets will always look at your home directory for this particular file for credentialing, for downloading credentialing. You can specify later on where you want your file to be downloaded to, but in this particular case, yes.
Mas eu podia ensinar uma coisa para colocar.
Ok, tá.
Eu não percebo, eu nem sequer o part lock nem sequer está bom.
Yes.
You have actually that's only if you have an Earth data username and password.
Okay, I don't.
Okay, so you can
So yeah.
But the idea is that you would put it here,
Yeah.
username and password.
ChatGPT.
But I won't comment on it too much. Put together.
Okay.
Anybody else had this problem?
Yeah.
Okay, fine. Yes, this is not the one. Yes. Ah,
DS,
yes.
yes.
Ah, okay, sorry.
No problem.
Okay.
Just see if something doesn't really work.
For me,
Yeah, for me.
All right, not
It didn't
supported.
work also, but now I know it's happening.
That means it's working.
Or it looks like it's working.
yeah, it's like the one with the most problems.
Right, not supported.
It's erroring.
Right function not supported.
Yes.
Okay.
No, for me,
Something regarding permissions that not being able to write. Having the correct permission and using that. It should just work, right? Up to this moment, everything works. I have no idea what's happening. It's the same issue.
The files are supported by the right function. But
You
I'm
want
using
these
that
files?
one. Yeah.
No,
right?
this
Yep.
one
Yeah,
is
see?
DS.
Maybe I have to put the full part.
No.
Should be there, right?
Ah, okay, yeah, I was missing.
Let's see, did I miss any package? Here.
Is it running?
Yes.
Okay.
Easy. Thank you.
which is kind of weird. Everything up to this moment is working perfectly. But
Yeah, well, I would have to investigate. I don't know.
But the error
That's,
is really strange. Do we need this?
We don't need it. We don't need it anyway. So yeah. Okay. So.
So long be that.
And the last step I would cover for today is actually how to plot, to make a nice plot of the C-stress temperature from the net CDF. We're just plotting using P-color mesh. It's similar to P-color, but it's a bit faster. Using longitude, latitude, and replace all the missing values by none. And so they appear white on the plot, and then we are also setting the correct aspect ratio. That's military seems not too stretched.
Just a note for the plotting. Julia sometimes does it slightly differently. Can you scroll up a bit? Julia deals with missing data differently compared to other programming languages. So what happens is that quite often when you load the data from netcdf, quite often instead of none for locations that don't have value, you have missing. PyPlot and other Python packages that you use to plot it will not recognize missing values. So you have to convert the missing values to NaN data, none data. So you have to use the function no missing in order no missing. It's very important that you guys remember this for plotting, because I've been tripped up on this many times before. Yeah.
And the error message, if you forget this, is not clear at all what's going on. If you forget it, it's something like
It cannot be converted to float basically, because missing is its own data type. It's separate from none. So just note. Yeah. Yes.
I don't have any errors, but I don't have any plots. In fact, when I'm reading also, I think it's problem with silent errors.
Try plot.show.
how can you using VS Code? You have to call. You have
For with Mackie, it's Python. PRT.
Data science doesn't have
and
Yeah, you cannot show the figure.
times the GCS open correspondence get VS Code works a bit different than
So you're saying Mackie doesn't
Yeah.
work for me?
Às vezes é não.
Okay.
Ou não. Yeah.
Interesting.
so I guess now
Não, dor de cabeça.
Yeah. Okay. That works. Okay, so let me close all these things, terminate, and let me share my screen. Okay. No, I feels off then. Hold on. Okay. Share screen. Share screen. Am I sharing screen? Oh yes, I'm sharing screen. Okay, very good. Okay, so hi everybody. Yeah. Hi everybody. So I'm going to continue off from. I'm going to take over for now.
Yeah, I just disconnected mine. Do you want me to?
Yes, probably. Okay, so today I'll be talking about creating packages and also about retrieving and analyzing geophysical data, or in this case geophysical data is satellite observations, and also potentially reanalysis data as well, like ERA 5 or MERA 2. But I also know that a lot of us here are very new to Julia as a whole, so I want to introduce some concepts that I think will be important later on down the line when you are developing your own packages in Julia. So the chief of this is that I want to introduce you to two packages. One is GeoRegions, which is selection of geographic data. The second one is NASA Precipitation, which is retrieval of precipitation data from NASA. But I want to use these as examples on how I created my packages, so you guys can do it more easily next time. So yes. Managing, the first one I'm going to do right now is managing package and project environments, which is basically when Julia works in this framework where you are able to activate different environments for different projects, and in different environments you can install different package versions. The fiddling of this is somewhat tricky and took me a few months to get a handle around, because 3 years ago there wasn't anyone to guide me through along with this process. But I wanted to do this for you guys, so it's easier next time when you are doing your own projects in Julia. Yes, and then based on the packages that I'm going to show you, I'm going to guide you through my process on how I created the packages, and maybe even sketch an outline for a future package that I'm planning to use. But using that as an example to show you guys how I went through the process of creating a package. So, first one, standardizing projects. So, the thing is that a Julia project or environment, in a Julia project, you will always have a project.toml and a manifest.toml. These TOML files define the packages that you have in your current project. So when you open your Julia, so when you go, let me increase the screen size some more. Okay, when you open Julia, and then you have when you do the square bracket, so if it's basically it's this symbol. If you do this symbol here, this square bracket symbol here, you do this square bracket symbol, you will go into the package management environment, where the package management environment you are able to you are basically able to add packages to a project. You are able to specify what version of the project, of the package you want to add to your project. You see here that this is v1.8. This is basically the version one. So basically when you start Julia, the default environment is the version 1.8 environment, and it is found in in your home directory in the .julia. If you go to your home directory, if you go to .julia and you go to environments, you will see that you will have different versions, or if you have different versions of Julia, you will have different versions, and you will have version 1.8, version 1.9, for example. If you go to version 1.8, you will again see project and manifest. And inside these project and manifest, when you type status, you will see a list of all the projects, you will see a list of all the packages that you have installed in this particular environment. So status, so basically the project contains a package list that you have, a list of packages that you can load in Julia, whereas the manifest contains the packages that you see in projects, and other packages which are dependencies of this project. So basically, for example, if my package NASA precipitation uses NC datasets, and I add NASA precipitation to the project, in the manifest you will see NASA precipitation and you will see NC datasets. But you will not see NC datasets in the project because I did not add NC datasets to my project environment. But my package depends on NC datasets, so it's inside the manifest. So is that kind of clear to everyone?
Yep.
So in the project you have a package list, and the manifest you have package plus dependency plus also version environment where you get your package from. So for example, if I went to the manifest, sorry, too many screens. If I open the manifest, you will see a list of all the dependencies here, and then if you have some special link to what's different to your project, you have a special version for a certain package, it will also show up in manifest. So basically, why am I showing you this? The reason why I want to show you this is because if you want to make your project duplicable for other people, I prefer not to use Docker. I prefer to use project and manifest files that will specify the exact package versions, package types where you use, so when you create a project, if you want other people to access your project exactly what it is, you have to commit your manifest and your project into the folder, into Git, and then when you share it, other people will download the project and the manifest. You instantiate everything in the package environment. It will store exactly the same versions of the packages that you have used onto your own computer as well. So in this way, you can ensure that your projects are reproducible. The thing is, this is for projects. This is for projects where projects like when you do a scientific project, etc., you want to use a certain version of a package, etc. But when you create packages, you will notice that in the repository, only the project is committed to the GitHub and not the manifest. Because for packages are designed in Julia are somewhat designed to be backwards compatible. So quite often designed to be backwards compatible. So you can't have something as specific as a manifest inside a package, or at least when you share your package with the rest of the Julia community, you will only be sharing the project.toml, not the manifest.toml. In your local computer, when you run and test your package, you will have a manifest in your local computer, but you will not be pushing that to GitHub. This is the difference I feel between a package and a project. In a project, you want everything to be exactly reproducible. That's why you need the manifest to be committed, but in a package, you don't necessarily need that because you have different package versions, etc. So, but in the repository, if in the repository shown here, this here, in the GitHub here, if I uploaded my notebooks and everything into this repository. If you guys want to follow what I'm doing step by step, you should just clone it into just clone the project, and then we can go through everything step by step as well at the same time. Yeah. So yeah. So and then one thing I was want to highlight is that you see that in the repository that you guys are cloning, the manifest is also committed because I want this to be reproducible for everybody. Okay, so I'm going to leave this here for another 30 seconds so that you guys can get the link, and then you guys can clone it into wherever.
Can you just download, if you don't have Git installed, can you just download?
I mean, you can copy the website, this link, go to the website, and then download the code. Yeah.
What was the is-bit?
We found the problem. Yeah, we found it.
Ah, you found it as well? Okay.
The guy back there helped us.
Ah, okay.
Basically, we were subsetting the wrong.
Yeah, you were saving, I guess. Yeah, you're subsetting the variable, this works, but you cannot save the variable as such.
Yes.
You have to save the data.
Exactly. So we had to subset the base.
Yeah. Oh, it looked like a really weird error because is bit is a really low-level concept in Julia. It's really
Exactly.
In new window.
Well, it's useful, right?
But if
Every
you
time
already downloaded it,
we break something, it's useful. Is that correct?
Yeah. No, next time I seen,
that's one.
I will think about it. Did you manage to clone?
I've already.
Okay, so who's downloaded or cloned the repository already? Okay. Who hasn't downloaded or cloned it yet? Okay.
Trying to connect.
Okay, so let's
It's cloning. No, it's crashing. It's freezing. So
Yeah, I'm giving credit to
it's
Bridge.
just
Frozen.
updating some package, but freezing.
okay, so for example, I have it. So for example, oh, where's the? Why is it not working?
Can you
You share.
Oh, yeah.
Stop sharing.
Yeah,
I'm gonna
okay.
stop
Sometimes
sharing.
it's happened for
I'm going to
5
share
minutes, but
this
it's okay.
again. Try this. No, it's not working.
Maybe the gigabyte of RAM, so maybe it's sufficient for Julia.
It's in the second screen. I see it too. In the left corner.
Let's see. I don't want to. I want it in mirror. I don't want to.
Yeah, it's kind of right.
Yes. Displays.
Yeah, so if you can access something here.
Let's do this. Okay.
Did you manage to clone? Okay.
Yes, I had the incorporate.
Share this.
It's working.
Okay. this, drag this, and then after that, I'll just put this here. Again,
The brackets?
It's okay.
That's just to
what?
instantiate. The next one is instantiate.
No, not working.
Also,
But is working here at
Yeah,
Zoom.
very good. Very good. Right, got this. Okay, so this is the project repository. In order to install the packages, what you have to do is you have to activate. When you open Julia, you always default to the automatic Julia environment, which is version 1.8 or whatever version you have. Can everybody see this? So if you want to activate the project inside this folder, you have to activate dot current folder. You activate the project inside here, and then in order to get everything working, you type instantiate. And because I've already instantiated, nothing pops up, but you guys should do instantiate in order to install and download everything, in order to install the packages that are here and compile them. So do instantiate.
Sorry, could you take the...
Yes.
Yeah.
Annoying.
Can you minimize in the...
This one?
Yeah,
Very
thank
good.
you.
Should be.
Is the instantiate working?
Yes.
Instantiate.
Instantiate.
What did you do?
I don't know. Now it worked. That's it. Enter.
And now,
You download it inside here, inside here.
activate again.
Yeah, yes.
The first
Yeah. I'll try.
but you can actually, so the first key is that you can also just go like this,
Update.
enter, execute this. So now you have
Okay.
so the name is the JuliaEO. That's
Okay.
Okay, if nothing pops out on instantiate, type update.
Instantiate is general function.
Yeah, see, you should be installing all these. You should see this thing pop up. Yes?
Just
Okay.
on this table. It's now test Julia to download all the packages and
Sorry.
At least.
Where is this?
Already out there.
Is it inside this folder?
Yeah.
Inside subfolder.
No, it's just directly there.
Okay.
normally Linux keeps a track
Can you type
the previous paragraph.
Okay.
So if you look in Varlog,
Yeah.
you might find something from what happens. Sometimes you see it had to change one process, or maybe there's one program which uses too much memory.
Yeah, this doesn't have anything inside.
Which one is the project or the
Instead of the version, appears
Escrevo.
Did you manage to
something was
Go back.
here this time? I don't know why. So I can trying to.
Activate just goes back to your code original.
Okay.
If you have already closed, you can just git update, so it should, any file was done, it should get the new version. It should, yeah.
Oh, because raw, if you need raw to and you cannot have a space up.
Yeah, nice, alright.
You must always yeah. How do you state? How do you get here?
So when you run activate, you should the directory contains the toml file.
That's what we want to state.
Yeah, if instantiate doesn't work, then type update. Try instantiate. If instantiate doesn't work, then go to update.
Open close parentheses. So there are two forms used with interact as a package manager. Sure. So let's move on.
Update if necessary, so
Whoa. Oh, it's not. Very good.
I'm gonna double check the manifest because if the other one has 4,
You can just download it if you want to.
No network.
Oh, set live.
Sorry, it's fine. But I was trying to check it.
Well done.
Because I need to go to the Julia, right?
Yes.
Oh my gosh. But can I install it right?
yeah, but it goes to a different folder, so it's
Created a project.
But there are maybe other files which are...
Yeah, but you don't have my stuff.
So
Yeah.
But I want you to go into my one and then install.
well, there's only
Do the installation.
I have your stuff.
Yeah, but I want you to go into that directory and install it.
Oh, okay.
Yeah.
Where can I see? The directory of your folder.
Yeah, that's
Okay.
yours.
To dependencies error.
Hmm?
This is
okay, great.
Okay, pre-compile.
Do you
Thank you very much.
So you can copy the file. Just come me that's you paste the file, but you remove the extension txt. Enter.
the folder is correct, right? Should be
The
this.
folder
this
is
one,
correct.
This one, right?
Yeah.
Yes.
The folder is correct because you installed NC and NetRC and stuff. Okay? Yeah. Caramel. Circle.
You can use not
Update.
Update?
and then you put the content.
No. You're not in mine. Are you in?
Yes, I'm in you.
Can I see where it is?
Yes.
Where's my stuff?
It's what I confirmed.
Um,
No,
So that's usually 3 users in the user.
No, it's not. It's not. It's not.
Yeah.
On the C drive, C users, and then you use a tag. That's typically the default location.
Faz print assim, eu não
Is that kind of working?
Yeah, I just downloading.
Okay.
I will finish one.
Is it working?
Yeah, I'm just trying to get a direction.
The home directory is on the C drive, right? The C username. So it's not the working directory of the.
It's not the working directory of your. It's in your home. It won't be. Which basically your user home. So in C, it's usually in C backslash whatever it is. For those who want to know what the directory, your home directory is, in Julia you can simply do home directory, home dir like this, and home directory brackets, and you should be able to get your home directory. If you guys need this anyway. But yeah, so but you guys notice, but like I said, when you clone the repository, the manifest and the project Toma, the manifest and the project basically clone exact duplicates of the packages that I use for this project, and I was going to go through with Dr. Watson. Basically, Dr. Watson is a Julia tool that you can use to manage your project workflow. So you can create a project with your project and your manifest, and basically create an empty project and manifest. And then you can go in and activate and add your packages to to your project, etc., etc. It basically streamlines the workflow. But I don't think I have time to go through this right now, but this is probably good for future use, like once you're more familiar with the concept of package and packages and environments, then Dr. Watson is very good at helping you manage that particular workflow. Because the aim of Dr. Watson is reproducibility of your projects, in essence. But I don't think I'm necessarily going to go through this right now. Okay, so I was going to make this an exercise, but I don't think we necessarily have the time right now. So what I'm going to do is I'm going to show you the differences between you can install different packages in different projects, and when you open two different terminals with inside different environments, you can actually see that if you install different versions of your package, you can actually you will be able to see this be reflected inside your environment. So for example, let's try this. Okay, so for example, in this particular project, I already have NASA Precipitation version 2 installed, for example. But if I went to a separate folder, and then what I did is that I activate this particular one. I'm just going to randomly create an environment, and then I add NASA Precipitation 0.1. So if I remember correctly, add basically means the version that means that you want to specify a specific version. So NASA Precipitation add 0.1. And you see that the version of NASA precipitation that I installed is version 0.1.2, which is, but because I specified as version 0.1, it can be version 0.1 point something, but in the latest version is 0.1.2. And then what I want to show you is that when I do this, so I loaded NASA precipitation in this particular environment, and for this one, I will load NASA precipitation in this particular environment. So the difference between version 0.1 and there are differences in version 0.1 and 0.2 in how I call my functions. It's reflected in the documentation as well. So, for example, I merge final day. So this indicates that I'm downloading the final product for daily iMerge data in version 0, and this is the documentation. This is the doc. So basically, you can, when you in packages, you should be creating your own documentation so that when you type help, and then you type your function name, you should be able to see the keyword arguments and stuff that you're using. So for example, in version 0.2, these are the important keyword arguments. But in version 0.1, if you type question mark, you get help, iMerge, final day. You see that the keyword arguments are different. So this particular instance shows you that I have installed different packages, different versions of packages in different environments. If you call them separate, when you activate different environments, you will call the different versions of the packages. But say, and the last thing I want to emphasize is that when you load a package, the package is loaded in this version for the entire session. So, in example, in this particular project, I have version 0.1. If I went back to activate my original one, and then I typed using NASA precipitation, and then I asked for help and I asked for the version, you will see that it's still the old version, the one that it initially loaded, because it has already been loaded. So if you want to load another version of the package or that I have already loaded, you have to close this instance and you have to open a new one. This just so you guys don't get tripped up next time. But that's basically a very, very short, is a quick and dirty summary of package environments and how you handle them. And there's a lot more to learn. There's quite a bit more to learn about this, but I just wanted to give you some examples of because I think this is important in best practices or in learning how to use Julia easily. Yeah. But that's what I wanted to show you guys. I wanted to have you guys do it, but some of you guys are having problems downloading, installing the packages right now. But I will upload the slides and you can try this yourself at your own time. But I just wanted to show you guys. These differences. Yeah. So yeah. One thing. Yeah, you can if. This is an alternative to going into the terminal and activate the current environment. If using Dr. Watson, you can use the function quick activate, and then you can quick activate. For example, if in my project HOML contains the name of the project. So, for example, in this particular case, the name of the project is Tropicals. So I can do a quick activate of Tropicals, and then you just activate the entire project for me. But that's a functionality of Dr. Watson. I thought things would be a bit more smooth, so I thought we'd be able to get to this, but it's just something that I thought you guys should know in the end. Yeah. So we can go. So now, now that we've kind of I've given you a brief introduction of packages, and hopefully some of you at least have managed to activate and instantiate and install the project without problems. We can go to the main thing, which is GeoRegions and NASA precipitation. So the first one is GeoRegions, which deals with gridded data. So a lot of this is not always the case, but in a lot of the products that I use, they are gridded products in longitude and latitude. So GeoRegions helps me to specify a particular geographic area. So if I have gridded data, for example, gridded data in this is just an example. If I could specify a geographic area, a boundary here, like the boundary in blue, and then my purpose of the project is that if I have this boundary in blue, I can just extract all the data that's within this boundary in blue, and then I can do whatever the hell I want to. I can do mean, I can do whatever. Yeah. So the important thing, of course, is that you have an identifier, you have a name for the region. So ID is like a shorthand, name is like the region, Indian Ocean, subcontinental India, whatever. A parent region, which is the default is the globe. So a parent region is a region that encompasses this region that you're specifying. The default is globe. For other reasons, you may choose it to be different, but it has to be bigger than this particular geographic area you want to analyze. And then you have two ways of doing this. You can either specify a rectangular region in longitude and latitude, or you can specify a shape where you give it a vector coordinate of longitudes and a vector coordinate of latitudes that specifies an entire shape that you can pick up in a longitude and latitude region. So in your project folder, you should have precompiled and ideally you should have precompiled and installed all the packages that you've needed. So what I want you guys to do is I want you guys to open the notebook georegions.jl and test out the functionality using Pluto. So Julia clean using Pluto. I think I might have forgotten to ask you guys to download and install. Have you guys downloaded and installed Pluto as well? Yeah, those of you who have downloaded and installed Pluto, you can use Pluto and then Pluto.run. And what Pluto.run does is that, yeah, you basically goes to the browser and you open stuff. And you georegions.jl, and just open it. Okay, so what I usually do is that I usually in this case I'm activating the current project, and then I'm using a set of packages. I think Gail showed this in particular yesterday, but his method was that he liked to do this he liked to put this at the end of the notebook. I like to put this at the front of the notebook because it's more in sequential order, because you have to load a package first before you run anything else. That's, and also this loading coastlines. The one thing that the one thing is that I don't think is that in this particular project I've also provided you with the coastline data. So read DRM is basically you're reading a delimiter file, CSV file or whatever, and then you look at the lines. That's just to let you guys know. So basically I have already specified a particular test region for you. Recall that in GeoRegions you can specify a rectangular region, north, south, east, west, the bounds, or you can specify a shape. The first example is a rectangular region. So all you need to, so basically here I've already had a sample region which is shown here, but what I want you guys to do is I want you guys to also create your own particular geo region here, using this example here. So this is the ID, this is the parent, this is the name, and these are your bounds in north, south, east, west. Yeah. And then save geo equals false means you're not saving the geo region. You're not saving it you're not saving it to be called later on. This is just a temporary one. So you can like basically copy and paste, and then you can define your own boundaries here, and then you can plot them later as well. Is the notebook loading? Yes, it's loading. Loaded. Yes, because it's Cairo Makey. Cairo Makey will take a while.
What is the name? Sorry, this is using HQ.
You know, it's geo region, which means you're not in the correct folder. Yeah, it'll take about, I think, a minute to load, because it's Cairo Makey. Cairo Makey. Yeah. Okay. Give me 10 seconds. TST is just basically the ID. The region ID, this is the parent ID, this is the name, and this is the bounds. Yeah. So now you can't everything you load everything here, right? So
I'm trying to define the region.
yeah.
You can move like the normal.
No. Pluto.run, that's it. Capital.
Okay.
No, you don't have to.
It will detect automatically?
No, it won't detect automatically. You have to just open the thing again. No. So, yes. Then it will give you a browser, and then you can go, and then when there's an option to open file. If you go inside the open file, you should be able to see it. Yes. So open a notebook. So here, this one. Click inside.
There's some stuff.
Yeah.
See,
There
Julia.
are some steps that we need to do. We can just go to the web page. Still have it open.
Something's not wrong. So why is it?
Yeah, it was because I was activating the...
Okay, so
And then what happened? Why is it not working?
there's
Oh, because NC datasets is not working.
I don't know if you need to do it's about
Let me see if I can find the error. I think because the problem is that what you're doing
You
is,
don't need to specify this. You just need to specify the coordinates, right?
you need to specify the ID as well. The problem is that NCDS is not loading on this side. NCDS is not loading on this properly.
interesting.
Let me see what does. Yeah, I don't know. It's the.
Andrea, do you realize
Pode ser na hora de 19, porque aquele cheio, sim, tem um retângulo, porque os retângulos, porque eles são cheios.
Não, quero o region ID e o parent ID.
Do you have
Mas se for do globo,
Conda installed?
You also need the Geo2 and this one.
I know, just here, but it should be global or shall I change? Because I'm going to look again. This is around this.
As in, it just needs to be bigger than this one.
Yes, it is.
So it's the globe is fine.
It just is.
It's okay now.
It's just ID. It's just the ID, but because you're not saving it, you have to save. So save geo means that you are saving it to be called in the future.
Alright.
You want another shell?
No. Oh yes.
Super.
Okay, what's kind
No,
of
this one.
is this?
Yes, you see this one?
It's nice.
Ah, okay.
I never thought that it man.
The AD library notes path, any library path.
It's definitely Cairo making. This is why I hate Cairo making. So
Can I just
yeah, you have to show it. And
so
then
sometimes
Perché
yeah.
questa contiera
overrides
Não percebi.
Porque o da terra interna, que é o G,
This one.
GLB,
try to just
como tá?
Como está? Ah, então deixamos assim.
Sim, sim.
Ah, deixamos assim, temos só a
Sim,
calcular.
sim.
Ah, ok. Então vai deixar perceber.
Try making it with 0 and 50.
Desse tempo, dizer
Like
que
your
não vai salvar de uma vez, mas não pode ser mesmo. É mais curiosidade.
Your east and west are a bit small. This north, south, east, west.
oh, okay. You have Julia installed 20.
If you want to make it bigger, like east, west, like 100 or east as 100 and west as 80
This
or
is
something
the
like that.
path where you start user lib to.
Yeah, and then this is north, south, east, west, and then east has to be bigger than 1. It's in the order north, south, east,
No. That's the problem.
west, east.
Because
West, east.
the libraries.
Are in one path and the
So when you use your Linux package manager, they use other libraries for code,
Okay.
okay.
and which are not the same one that I'm using.
Yeah.
Okay. So
Guys, can I take yours?
Can
you try doing the test?
So that's what I do.
Have you tried
I
making
always
your
use
regions?
the official binary.
Yeah. So see here,
I
I
asked
have
the
a sample up here. You have I have a sample up here.
management tool.
I want you to create a second one
Can you
below.
Google NC data set?
I want you to create a second one below, and then you can load all the coordinates.
Can you just change the coordinates?
Copy everything.
Yeah.
Yeah, you need because you're specifying that it's a record.
So there might be a quick way to solve it.
Yeah.
So we need to tell.
Yeah.
Go and GitHub. Oh yeah. Or docs. What about known issues?
It has been north, south, east, west. North, south, east, west.
Sorry, okay.
No, your north has to be
Using
bigger than south.
custom let's look at it. Okay.
North, south,
Can you on your
east, west.
system
Okay.
type locate netcdfso in the shell command? So we have to know where this library
Run
is.
its
Yes.
Okay, so you can you install it?
And
What distribution is this?
Arch.
yeah, scroll up. See, we have a second one up here.
Okay.
I don't know if it's called an arch lib netcdf, which is netcdf.
Is it?
No, I
But you have to be root.
I know what I do.
Try this with root.
You should uncomment this one.
That's
Why
fine.
you just do the geo? Yeah. Because because north, south, east, west.
Oh, 29, menos 59.
Não, 30, menos
Your
29.
northern boundary is
Menos 29.
more south than your southern boundary.
Aliás,
Yeah, locate does not
Ao menos
direct
27,
update.
Ah, menos
so-
27, menos 28.
So your history will be
Can
correct.
you?
Yeah.
Oh, it will take a while.
Yeah, east, west, east, west.
Can you carry your package manager to see
No, no,
what
east
files
is
are in the package?
East, north, south, east, west. Yeah.
Oh, the updated work. Okay. Now we can so. Or did you interrupt it or?
No,
finish? Okay, now let's try locate again.
The FTTB, I think.
Okay.
I stopped.
Okay. Okay.
Okay, now we have something.
We have something. So this is the one which comes with NetSDF. That's not the one that we're using. We use this one.
No, no,
So you
you
can.
can, I just want you just to see the two of them. Yeah.
Situation and select.
You
You
scroll down,
have to
and then you uncomment
copy
them.
to. Then I'm using copy. So you have to copy. Can you copy this? Yeah. Yeah. You have to execute it in Julia.
Whichever June instance I want, or a specific one.
Let's try it here first.
This one.
But I guess we have to do it in both places.
So yes.
Is this in the
Okay. Error?
Nope.
Okay, that's the same error as before. Let's hope that's okay.
There's the bracket.
Now let's try to execute the second command.
Oh, no.
Mhm.
Natalia. Warn
No, no, no.
there are
Yes, the second one.
This one.
I use the second one.
The second one?
Usually the first one is just a link to the second one.
Okay.
I think it doesn't matter, but and let's hope that it works. I'm not sure. Maybe, yeah? No. Yeah, that's the problem that we could not load it before.
No, this one needs to be packaged. Because I know why.
Mariana, não se usa negativo para o hemisfério ocidental.
Não?
Não. Vai ter que ser mais 180. É isso, vai.
É, isto vai de, vai de 0 a 360.
Então, como é que é?
No, I think yeah.
Usa negativos, pois.
I think we need to install Julia.
Então, é mesmo mais
Vai de,
Exato.
vai de oeste para este,
Oeste para oeste.
340 a 325.
I can a lot of work.
Então, é 39,
Yeah, I'm not
38
sure
e depois menos.
Não. É menos 27 mais 180.
Sim, mas a primeira parte.
Ah, ok.
39, 38.
Ah, sim, a latitude está certa.
Sim.
É só as longitudes, sim. A latitude sim, se usa negativo, mas a longitude não. Pronto. 180 menos 25. 17.
Okay, so that's for a rectangular region. And it's also possible to do the same for a non-rectilinear region, or rather a shape. So basically this is an example, a poly region, a polygon region. And then this is for example, this is for South Asia, for example. The Indian subcontinent, for example. Based on the time, I don't think we have to do this anymore. But what I wanted to show you is that you can do basically here you have a land sea mass. So basically it's this is the topography. This is the Earth topography here, and you can basically create something from. So basically this is a georegion. And you have the longitude and latitudes loaded for this topography here. What you can do is that you can create a grid region from the original global longitude and latitudes. You have
a georegion, and you can extract gridded information for that particular georegion. And then you can extract it, and then you can just plot it like this. It's already 12, so I think we ran out of time, more or less.
5 minutes.
Yeah. So, but this is what I wanted to show you for georegions, that you can do an extraction of. You can do an extraction for gridded data sets, and then you can and then you have the you can just do the analysis here.
So it's like a shapefile.
Kind of, yeah. But I feel like it's just more basic.
Yeah.
It's easier. It's more basic than shapefile. There's no more. There's no like have to conversion between this and that and that and that. Specify your shape. Grab everything. And then if you want, and then I just recently added functionalities to get the etopo grids. But I think that's something that you can explore on your own. I will have the documentation for all this up in maybe a month or so, because I need to go back and revise the documentation again. But I will be putting out updated documentation for all of this eventually, probably in a month or so. But I just wanted to introduce to you this particular package here. Yeah, and then you can use this to define and download data sets from other, for like reanalysis or satellite data sets. So yeah, so I actually just wanted to go through a lot of different things, but okay. So you guys mind me giving like a 5-minute summary of everything left? Okay, so basically you notice that you have a rectangular region and a poly region. These are types which I think other people have mentioned, but this is how you define your different types here. So you have, so basically each struct is a different type, and then you have your fields within your struct. But the thing, so for example, so in georegions you have different types, and then different types when you pass different types. For example, you see this one, a rect region for this particular function called georegions has a particular method. If you do a poly region, you see the method is different. You see the function is different. You have the same function name, but you can do it such that for you have the same function name, but if you give it a different type, you give different results. So for example, like a rectangular region is just a rectangle. So you only have the bounds is the same as the shape. But for a polygon, you have the shape and you have the north, south, east, west boundaries. So coord georegion, for example, if you pass it a rectangular region, you will only get the bounds, whereas if you pass it a polygon region, you will get the bounds and you will get the shape, and you will be able to plot that shape separately from the bounds. So the bounds will be like a rectangle, and then you have the shape inside. Yeah. So this is what we call multiple dispatch in Julia, where you have different function, where you have the same function name, but depending on what type you put into your function, you can get different results. So for example, if you want to download something, you can just use the function name download. But in the download, you specify a different method. You specify you specify a type, for example, for INSAR data. You can just use the download method for INSAR data, and then you run through a completely different method as compared to if I had a download function for precipitation data, for example. You can do this using struct types. Yeah. So you can also do topography. Now, precipitation. I wanted to give you guys an example of how I applied georegions to this. So yeah, I was going to say that using types is easier than using dictionaries, because essentially when I first started out, I was using dictionaries and it was messy as hell. But if you use types, everything becomes a lot simpler. So you see, for precipitation data for NASA, for example, you have trim, you have image, you have hourly, you have daily, you have monthly, but you can all do download, because I have different types for different data sets. Yeah, a lot simpler, a lot easier. So for example, so yeah, see, I merge half hourly every 30 minutes. I merge daily, and and the thing is, you can just do this because inside each of these struct types, you can contain information that will give you the path, that will give you the website or the link to download this from, and it's different for different data sets, different types, and then you can just download, and then it goes, yeah. So basically, I was also going to say that NASA precipitation uses NC data sets. There's a lot of nifty tricks in NC data sets. For example, if you load, so basically, best practice during coding is to not keep defining new arrays inside because when you have for loops, right? If you want to modify an array, you don't want to keep redefining the array and reallocating it because that will take up a lot of memory. You can use NC datasets to load stuff in place. I will be putting up these slides so you can have a look at the code later. But basically load in place inside a temporary array. But just a note, because what I did is because I use and after that I use georegions to specify the longitude and latitude coordinates that I just wanted to grab, so I didn't have to download the entire file, which is big. I can save space and download only the data I need. Yeah. So you see the example on the right, yeah. And then for loops are fast. And if you use NC datasets, if you open large files and you keep loading the data, it might cause memory overflow. So it's always best to use in-place loading. You define one array at the start, and you just load in place and you keep replacing the data, for example. So you load and then you load and then you save. Yeah. I wanted to introduce view, which allows you to split arrays, but view is commonly used to just view certain segments of an array, save memory much faster. And then I also just wanted to outline how I created packages. So for example, I have a package, I have different components, and I also have actions. So for example, NASA precipitation, I have the components, which are the data sets and the geographic region. So I specify the data set that I want in the geographic region, and then I perform the action, which is the download and the extraction and the analysis, for example. So examples, if down here for NASA precipitation, I have for data sets. I have an for data sets the different, so I specify all the different data sets in structs, example, and I have functions that will tell me for each data set. For example, if I call the iMerge hourly, the iMerge half hourly already has a specific link or specific website address that you can just put into the struct and define it there, and then after that you define it here, and then it's very easy from there on, after you define the data set here, to then use it in download and extraction and analysis, for example. Yeah. Same for ERA 5 view analysis. You have data set, you have geographic region, but you also have like a variable, so you want to specify the different variables like pressure, temperature you want to download, for example. So again, here, data set, region, and variable. You specify these three, and once you specify these three, then everything else will come more or less naturally. You just have to do multiple dispatch to, and you have for different function types for different downloads. So you have different methods for different data sets and different regions. So but this is kind of like the workflow process that I've been using, and I wanted to go through Merato as well, but I was like, how do I group the different data sets? How do you have lists? How do you define the variables in relation to the data sets? Because different data sets were different variables, for example. So what should a data set type contain? but I don't think we don't have time to do this right now. It's already 12:15, and I'm sorry for keeping you guys over time, but
it was super necessary.
yeah, but I will upload all these and you can peruse at your own time, and if you have questions, you can always reach out to me and I will answer them as best as I can. Yeah. So yeah, that's kind of what I wanted to go through. Is there any other questions?
This is not a question, it's just an observation. Thank you. I'm very new to Julia. This is my first experience with Julia, and this has been the most helpful thing.
Yeah.
This should have been the first
Exactly. This has been the most helpful thing until now for me.
Okay. It was like they actually wanted to arrange it for the first day, but they were like when you reached out to us, it was the last day, but they wanted to push it to the first day. But there were time commitments and issues, so people couldn't.
Yeah.
So sorry about that, but
no, because now we're going home a lot.
More prepared.
Yes.
We now became more Julian, all of us.
Yeah.
Lighter.